I'm going to run through this week's lab, which is some ordination work. We're going to be looking at community analysis of multivariate data in RStudio here. So I'm just going to run through how to actually do the lab in RStudio. There's a lot to read here in the lab. It's important that you read that. I'm not going to walk you through that. This is duplicating what I have on some other videos, so I'm just going to go straight down to actually running the lab in RStudio. So first of all, there are going to be two data sets, com.data CSV and env.data .csv. One of these has all our community data, all the data we're interested in ordinating. It tells us about the shape of our community. And then the other data set is about the things that we are hypothesizing are driving the community. This comes from permanent plot surveys in the Evergreen State College Forest Reserve. So we're looking at how plants are arranged in communities in the Forest Reserve and what drives that. So first of all, we're going to work with RStudio. So make sure RStudio opens for you. Read these instructions in detail if you haven't done that before. You're going to open RStudio, and then to import data into RStudio, you're going to choose Import Dataset from Text. And then you're just going to go ahead and import that. When you select to import the data, you're going to get an option to surf to where the data is located at. In this case, I have the data located in my Stats 7 lab, and so it's navigating there. I'm going to go to the data I'm looking for, which is com.data first. I'm going to open that. When I open it, it's going to ask me if I want the headings to be included. I'm going to say yes and import. There's com.data. Next, I'm going to import the environmental data, which is going to be similar to what we just looked at. It's going to be called env.data. And on a Windows machine, the navigation pane is going to look a little different. You just have to surf to the data and grab it, and then make sure to click heading yes. Both my data sets have now been imported into R. If you're using RStudio.cloud, there's an additional step that you have to do in the lower right-hand pane in order to get that data available for import. Now that that data is there, let's skip down and do what it asks us to do. It's going to have us look at the structure of the data, both the com data and the environmental data. If I copy all the text but not the caret, I can paste that text and it will just do the command for me. I can use the up arrow in RStudio to just recall a command that I liked before. Okay. So in this case, I like the command strdata, and I can just recall that and then do it again. In this case, I want strenv data. That's the next command that's over here in the lab. I can copy and paste that, or I can just edit it here. And there we go. You'll notice that when I do this, it's going to give me a rundown of the structure of the data set. What variables are factors with multiple levels, i.e. for example, these are indicated by words rather than numbers, and what variables are numbers or integers. I'm going to rename my data set. This is really important for the com data set. This command here that I just highlighted, and I'm going to paste right here, uses the reverse arrow command to take an item that we've already identified, com.data. That's what our community data was named when we brought it in, way up here at the top. And the reverse arrow is used to indicate that we're going to rename it whatever the text is starting with. So R is working a little bit backwards in the way that it does this operation. It's first identifying what we're going to call something. Then it's using the reverse arrow to say, put in this item we've identified, here's what I want you to put in there. And then And then the thing we're interested in is at the far right. And in this case, the square brackets -1 means subtract the first column. So what we're saying is, to decode this text, we're saying take COM data, decode the first column, then put that in the letter COM. And so whenever we type COM, then we're going to get that data set without the first column. Okay, enough of that. Once I've done that, I could do the same thing with ENV data. Just copy and paste this text. In fact, it turns out you can copy and paste all this text if you're interested in it. Just don't copy and paste the caret, since the caret is part of the code that's here. These hashtags here tell R to not pay attention to whatever's between the hashtags. So it'll work just the same. We can just go ahead and copy and paste text for a while here to make sure that everything works as it should. There are a couple packages that you have to install. First, we have to install vegan. In this case, I've already installed it, and so I don't have to reinstall it, but it gave us that option, so that should work for you. You can do the same thing with other packages that we get. After we've installed a package, we have to load it, and we load it using the library command. So library parentheses package that we want to load, in this case vegan. Another way to load packages is to go to the packages tab here and use the install button to search for and install the package you're interested in. Once vegan's running, we're ready to do the first big command that's part of this lab, which is species accumulation curve. After I run this, I'm going to stop, and I'll leave the rest of this for the next video. So species accumulation curve runs with the code that's right there in the lab. It's using the data COM, and COMM is what it needs. It needs to know that that comes from the data set COM. It's going to use a random method for generating our species area curve, and it's going to use 1,000 permutations. So that's consistent with what you probably did in a previous lab. So up to this point, should be consistent with what you've seen in a previous lab. Here's a species area curve generated from the data. So make sure you can get this far. Once you can get this far, the rest of it is going to be relatively easy, cutting and pasting the text as you see in the lab.